All right, everybody. So we left off the digestive tract right after the stomach, and that is definitely not all the story. That's not even half the story. Most of the digestion is actually going to occur in our small intestine. So we're going to start there. So just as a recap, we just left the stomach through the pyloric sphincter. From the pyloric sphincter, we're going to go into the small intestine. Now remember, we're going to send some hormonal signaling over to this pyloric sphincter to control the emptying. You don't want to dump everything from the stomach to the small intestines at once, because you remember, some of you might know this reference, some of you might not, but the I Love Lucy episode with the chocolates on the conveyor belt, she's trying to grab them and it's just too fast. And I've heard there's something with Drake and Josh with the sushi that's very similar. So you're trying to make sure it doesn't rush past the small intestine too quickly, that it doesn't have time to grab the nutrients that it needs. So the pyloric sphincter is going to control the emptying from the stomach. So now we're going to go from that pyloric sphincter to the small intestine. Now the small intestine is going to have three parts. The first part is the duodenum. I've also heard it pronounced duodenum, duodenum. It's both the same thing. So, or duodenum. That's the third option. So duodenum, duodenum, all of that works, is going to be where you're going to have most of your enzymes dumped in, because that is really going to be that first part. So let's get all the enzymes in there right away so we can start chemical breakdown. Then from there, we're going to go jejunum and then ileum. So this one's going to receive secretions from pancreas, and then liver, and gallbladder. So as I mentioned, they get a lot of secretions there. Now these two, the secretions, are both going to have the same function. The liver and the gallbladder are both going to be secreting bile. The liver specifically is what produces it. The gallbladder stores it and concentrates it, which is why you can live without a gallbladder. I've actually had mine out, and look, hey, I'm still here. We can live without them. You just won't be able to eat as much fat, because the job of bile is to emulsify fats. Remember, fats don't like water, and we're secreting a lot of mucus into this tract. There's fluids, there's water that we also bring in when we eat. There's water being released from the food as we break it down. So those fats are going to kind of clump up together, and we got to figure out how to get those enzymes to as many of the molecules as possible. So we're going to have all these fats kind of clumped up all together, and we're going to take this bile and we're going to use it to emulsify and separate them out. So it's not breaking my markers, we're not digesting them, we're just moving them into different groups. So it's kind of like taking a lava lamp and shaking it up. This increases surface area though, so that we have more access to the molecules for the enzymes to do the work. Now speaking of the enzymes, that's what's coming from the pancreas. So the pancreas is going to release a variety of things. And some will go towards the small intestine, and others will go into the bloodstream. So let's talk about that first. Don't forget the pancreas is an endocrine and an exocrine organ. Forgot that word. So with this one, we do have two things that we can put into the blood. They both deal with blood sugar levels. We have insulin and glucagon. So the trick is glucagon is released when glucose is gone, so it'll help increase blood sugar. Insulin is going to be its opposite. And then into the duodenum, what you're going to secrete will be basically enzymes for breaking down all of the major nutrients. So we'll have lipase again, we'll have amylase, we'll have nucleases, and then we'll have proteases. Proteases are the protein digesters in an inactive form. Remember, we talked about that back with the stomach. You cannot produce protein digesters and store them inside of your cell, because they will eat the cell and digest their little storage area and kill you. Bad idea. So you have to produce them in an inactive form and secrete them and have them become activated here. Now you will also secrete into the duodenum some buffers. So this environment is not acidic like it is in the stomach. So we have to have a different plan for how we activate these proteases than what we use in the stomach for the pepsin. Remember, pepsin becomes activated when it hits an acidic environment. These ones will become activated because built into the wall along this digestive tract is a really cool feature. So along the wall of the digestive tract, so I'm going to real quick kind of shorthand do this, we're going to build the enzymes actually in the wall. So they're not always getting lost with the food. So the ones that are built into the wall are called your brush border enzymes. Their jobs, for the most part, so most of them, are for the final breakdown. So they're taking things like a disaccharide and turning it into a monosaccharide. So lactose is going to be broken down by an enzyme called lactase. Maltose is going to be broken down by maltase. Sucrose breaking down by sucrase. So you're breaking it down to the final piece to bring it in. But there are some there that are designed as an enzyme to activate one of these proteases. So trypsin will be secreted as trypsinogen. So trypsinogen is a specific example. So let's do that over here real quick. So in active form, so trypsinogen going in from the pancreas to the small intestine. So here we are in the small intestine. On the wall of the small intestine, you will have an enterokinase, which will activate trypsinogen and turn it into trypsin. Active form, we lose the gin part. So trypsin can break down proteins. Now remember, enzymes are made out of proteins. So some of the other inactive ones that were released, procarboxypeptidase, for example, can be then activated by this particular one. So if we have an enzyme to make trypsin, then that trypsin can then activate the other one. So it's going to be a cascade of reactions there. So that's what's kind of happening here. Now, as far as looking at it and kind of getting to see some of the anatomy here, this is what we're looking at. So here's the pancreas, here's the duodenum. Duodenum's not very long. The main job of the duodenum is to neutralize the acidic food that we were just receiving from the stomach and also receive the secretions from the pancreas, liver, and gallbladder. Now, liver would be right about here, but it is missing. Gallbladder is hanging out here. That's that little storage bag. And then, like I said, that's pancreas, but it's not all there. There would actually be a long tail that continues. So we have a main pancreatic duct right here, dumping right there. We have then gallbladder there, and as I mentioned, liver here. So if we come off the liver, you would have a left and right hepatic duct. So those are the left and right hepatic ducts. They merge to a common hepatic duct, right? Because you're left and right, then it becomes common. It can receive some from the gallbladder. So this is the cystic duct right here that connects. And the reason why I can also remember that cystic is it makes it look like the letter Y. Once you get bile from either the cystic or the common hepatic, now it's considered a common bile duct. So the bile duct connecting basically from either of those organs, the one that makes it or the one that stores it. And that delivers down here. Now they're both dumping out what is called the hepatopancreatic sphincter. Hepato meaning liver, pancreatic for pancreas, and there's a sphincter, a ring of muscle that controls when those secretions do get emptied into that small intestine. Okay, so let's kind of continue on our journey. So we'll dump things into the duodenum. Your jejunum will have the majority of your folds. So if we take a look at it, if you kind of compare the three, your jejunum has a lot more folding. This is where most absorption will occur. That's why you have an increase in surface area there. It also fits in some more of these enzymes that are doing that last step, so those brush border enzymes. Then when we get to the ileum, we don't need as many folds. We're kind of finishing up that absorption process. So that's your small intestine. So we'll kind of group these together real quick. Now to get from small intestine into large intestine, we're going to pass through a ring of muscle. This ring of muscle is going to be the ileocecal valve. Ileocecal valve should make sense for name, ileo, because one side's the ileum. Guess what's on the other side? Yep, it's the cecum. So first part of the large intestine. So if we're looking at the large intestine, it looks somewhat like this. We're going to have the cecum as this bigger pouch right here. Then we're going to go colon, so we'll go up, across, down, make a C shape, and then we'll finish in the rectum. So there's three parts to large intestine. So cecum, colon, and then rectum. And then of course, there are parts that have parts within parts, so we should talk about those as well. So if we go from ileocecal valve, we'll go into the cecum. And then that, as I mentioned, is that pouch right here, kind of right where my hand is. And that has the appendix off of it, if you still have yours. From cecum, then we're going to go into the colon. Now, specifically with the colon, you're going to go into kind of a box shape. So we're going to go up first. So we'll have the ascending colon. From the ascending colon, we're going to make a turn right here. And this is a turn over by the liver. So this is going to be the hepatic flexure. So think about it as like where it's flexing, and it's telling you what organ it's doing by. You can also call it the right colic flexure because you're on the right side. Then we're going to go across. So that's going to be our transverse colon. We're going to make another turn, but this one's over by the spleen. So this would be splenic flexure. From the splenic flexure, oh, also left colic flexure. We're going to then go down. If we're going down, we're going to call this the descending colon. And then from there, there's a last one right here. And do you see how it looks like the letter S? This is the sigmoid colon. From the sigmoid colon, we'll then enter this last little area, which is the storage area. That's going to be the rectum. With the rectum, at the end, that's the anus, and there are going to be 2 rings of muscle there. So rectum, which will have the anal canal. And part of that anal canal will be 2 rings of muscle. The inner ring of muscle is smooth muscle, involuntary control. The outer ring, you definitely have say over, thankfully. So that one's skeletal muscle, so different materials. So that right there is going to make up your large intestine. Now with the large intestine, your major job here is to pull water out of this so you can then compact your feces and store it and eliminate it as more of a solid. You can retain that water, and also you will absorb some vitamins. Nice thing about that is actually coming from bacteria. You have bacteria that live here. This is your natural flora, and they're making, as a byproduct, because they're eating your basically leftover food, the stuff that you didn't absorb and didn't want, and they're going to make some vitamins for you, kind of like think about it like paying rent. And so then you can absorb those vitamins that they're making and get some benefit from it. All right, everyone, I hope you enjoyed looking at and talking about the rest of the journey through the digestive tract. Thanks for watching.